Okay, so we're going to talk about graphing precisely when your a value is less than a half. So it's going to be basically the same procedures. It just you're going to have to remember how to do. You're going to have to try and do a couple different things. So if we use Desmos to sketch y or f of x is equal to 4x squared, what you're going to get is you're going to get kind of a narrower version. Okay, and that's because this right here, the graph goes up quicker. Okay, this right here is your slope. Your slope is going to be steep. For this one here, 1/4, what you're going to get is you're going to get a much wider graph. And so you set those expectations, especially when you're looking at things like multiple choice tests or when you're graphing, to make sure that your graph kind of looks right when you graph it. So when a is greater than 1, the graph is going to be narrow. When a is less than 1, the absolute value of a, so whether it's positive or negative, it's going to be wide. Okay, so I have a couple tips. There we go. I have a couple tips here. When finding the vertex and you're dividing by a fraction, remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So this one right here, if I have 8 over 2/3, that's the same thing as 8 times 3/2, which is going to be 8 times 3 over 2, which would be 24 over 2, which would be 12. Okay. The other thing is pick, when you're filling out your table, the rest of your table, pick x values that are divisible by the denominator of a, or if they're squared, they would be divisible. So if you have 1/3, you're probably going to want to pick numbers that are divisible by 3, so you have nice points to put in your table, so you can plot some nice clean points there. Okay. So for this first one, first thing we're going to do is we're going to find the vertex. So I know my a value is -1/2 and my b value is -1. So we use that. So x is equal to -b over 2 times a. Now you can do this by hand or you can put it in Desmos. So I'm going to go through -1 is +1, 2 times -1/2 is -2/2, which is the same thing as I simplify -1, and so it's just going to be -1. So you can do it by hand, or you can go to Desmos Scientific Calculator, and you see here, okay, do my fraction, make sure negative, anytime you do some sort of substitution, especially with negatives, put it in parentheses, 2 times -1/2, and you see that you still get the same thing. You still get the -1. So you're more than welcome to use Desmos. Just make sure you put parentheses around that in order to get your x and y value. So my x value is -1. To find my y value, I substitute it in. It's going to be -1/2 times -1 squared. Again, make sure you put those parentheses there, times -1, which is going to be -1/2 times 1 plus 1, which is -1/2 plus 1, which is the same thing as -1/2 plus 2/2. I can go through this, but you have to find a common denominator with your fraction to add fractions because they need to be the same size. And so my answer here is 1/2. But again, you can take this and you can put this into Desmos and it'll give you your answer as well. And the same thing for the other points. I just want to make sure that you're picking the correct type of points. So my vertex here is -1/2. I know that since my a value is negative here, I know that it's going to be concave down, which means that this is going to be a maximum. And I know my axis of symmetry is going to be the line x equals -1. So I graph this. I graph my point, -1/2 would be just about there. I am going to just kind of put in my axis of symmetry, just so you guys can see that when I plot my points, I should be able to fold my graph over and it should be able to fold on top of itself. Now let's get to picking points in my table. So I need to pick a point to the left, and it should be, when I square it, divisible by 2. So I know that if I plug -2 in, well, I know -2 squared, I can divide that by 2. So that's what I'm going to pick. So it's going to be 1/2 times -2 squared minus -2. Again, you can put this into Desmos. -1/2 times 4 plus 2. -2 plus 2 is equal to 0. So -2, 0 would be 1 point on my graph. I do the same thing. I also pick another number. -3 is not going to be divisible by 2 when I square it, but -4 will be. So I'm going to pick another point. I'm going to pick -4. So this is going to be -1/2 times -4 squared minus -4. Make sure you put your parentheses around that, especially if you're using Desmos. -1/2 times +16 plus 4. -1/2 times +16 is going to be, is -8 plus 4, which is -4. Okay, so -4, -4. Now, in theory, okay, I can use my axis of symmetry. If I have those 2 points plotted, well, I know that this point is 1 point away, so if my graph is symmetric, then I should have another point here, and then this point is 1, 2, 3 spaces away from my axis of symmetry, so I should have 1, 2, 3 spaces the other way. In theory, I should have these 2 points if I did the math right. So, I mean, you're more than welcome to just kind of plot those other 2 points for your 5 points and then write the values there. But I'm going to do a check first before I do that. So here I have my -1. 0 always works. 0 is always a really good value to pick. So I'm going to do -1/2 times 0 squared minus 0, which of course is going to be 0. And so, yep, that point did work. So it looks like I did find my points correctly. And then I'm not going to pick 1, I'll pick 2. -1/2 times 2 squared minus 2. So this is going to be -1/2 times 4 minus 2, which is -2 minus 2, which is -4. And you'll see these points are the same, so -4 did work. And so there's my graph. And there you go. And so you can use your axis of symmetry because it's going to be the same number of spaces. So this is 3 spaces, so you're going to have another point that is 3 spaces. This right here was 1 space away, so this one here is going to be 1 space away. Okay, I just have 2 more examples to go through. Number 3 is actually a little bit more important, but let's just go through number 2 here. So number 2 here, I know my A value is 1/4, my B value is -3. I know to find my vertex, it's going to be -b over 2a. That's going to be 3 over 2/4, which is 3 over 1/2. And I gave you that hint at the very top of the page that when you divide by a fraction, you multiply by the reciprocal. Okay, so I can flip it and make it into multiplication. So this is going to be 3 times 2 over 1, which is 6. And again, you can always put this into Desmos. Okay, so I know that the x value is 6. I know that this is positive, so my graph looks like this. So this is going to be a minimum. Okay, and I also know my axis of symmetry is 6. I'm not ready to quite graph that because I also need the y value of my vertex. So to find my y value, I plug it in. You can again do this in Desmos. 1/4 times 6 squared minus 3 times 6 plus 2. Okay, that's going to be 1/4 times 36 minus 18 plus 2. That's 9 minus 18 plus 2. 9 minus 18 is -9. -9 plus 2 is -7. And you can check that with Desmos too. So we can do 1/4 times 6 squared minus 3 times 6 plus 2. Press enter and you see that you do get a y value as -7. Okay, so now it comes down to picking, so I'll plot my vertex first. That's going to be 6, -7, okay? And I'm also going to draw my axis of symmetry. So you only have to actually technically, if you do the math right, you should only have to find 2 points, okay? Because then you plot the other 2 points on the other side. So now I'm going to be looking for, I'm going to be picking points that are divisible by 4. And you can go to the right or to the left. I'm going to pick, I'm going to just use 4 here. So I'm going to plug 4 in because I know it's divisible. I know that 4 squared is divisible by 4. So it's going to be 1/4 times 4 squared minus 3 times 4 plus 2. 1/4 times 16 minus 12 plus 2. 4 minus 12 plus 2. Negative 8 plus 2 is negative 6. Okay, so we have 4, negative 6. Okay, let me pick another point. So I'm going to actually pick, so 4, let's go to 2. Okay, now 2 isn't divisible by 4, but 2 squared is divisible by 4. So that's why 2 is okay, because I know that right here I want to get rid of this fraction. So if I square it, I know that I'm going to be getting rid of that fraction. So this is going to be 1/4 times 2 squared minus 3 times 2 plus 2. 1/4 times 4 minus 6 plus 2. Okay, that's going to be 1 minus 6 plus 2, negative 5 plus 2, which is going to give me negative 3. Okay, so that looks good right about there. If you want to, you can either use symmetry. In theory, since this would be 2 spaces away, then I'd have another point that would be 2 spaces this way. This is 4 spaces away, so in theory I should have another point right here. You can graph it like that, and you can say, okay, well this is 8, negative 6, so 8, negative 6 should be another point, and then 10, negative 3 should be another point. I'm just going to check really quickly. I'll just check the 10 just to make sure that my answer is negative 3. So I'm just going to do 1/4 times 10 squared minus 3 times 10 plus 2. That's 1/4 times 100 minus 30 plus 2. 25 minus 30 plus 2. That's going to be negative 5 plus 2 is indeed negative 3. So I know that this is fine. Okay, those points are going to check out. But again, if all you want to do is do 2 points and then graph the other 2 points on the other side using the axis of symmetry, you can do that as well. All right. And you can see that this 1/4 is going to be, your parabola is going to be a little bit wider. So there you go. So this is 2 spaces, this is 2 spaces, this is 4 spaces, this was 4 spaces. So that's what all I was showing there. Oh, and I forgot to write the y value of my vertex, which was negative 7. Okay. Last one, I promise. This one is just a little bit more challenging. So for this, I know that A is going to be negative 1/3, B is negative 2. So when I find my vertex, it's going to be x equals negative b over 2 times negative 1/3. And again, Desmos will do this for you, so you can actually put this in your Desmos calculator. For those of you that want to math it out, this is going to be 2 over negative 2/3, which is actually equal to 2 times 3 over negative 2, which is going to be 6 over negative 2, which is negative 3. So I know the x value of my vertex is going to be negative 3. I also know that my axis of symmetry is going to be the line x equals negative 3. I know that this is concave down because it's negative, so this is going to be a minimum. Okay. Find my y value. Negative 1/3 times negative 3 squared minus 2 times negative 3 minus 4. So that's going to be negative 1/3 times 9 plus 6 minus 4. Negative 3 plus 6 minus 4. That's going to be 3 minus 4 is negative 1, I believe. Okay, so negative 3, negative 1. Okay, that's my vertex. Alrighty, just knowing my vertex and knowing that it's going to be concave down, even before this, even without actually graphing it, I know my domain is going to be from negative infinity to positive infinity. And I also know that because this is concave down, that this is going to be a maximum. So I know my range is, it's going to be coming up it's going to be coming from the lower parts. It's going to be going from negative infinity, and then the highest point would be negative 1. Oh, don't need that there. So you can actually figure out the domain and range without finishing the problem. But we could actually do all of this just knowing that what the vertex is and whether it's concave up or concave down. All right, let me just go through. So I know my axis of symmetry is at -3. So I'm just going to plot my 2 points. So this is at -1. What values am I going to pick? So this is -3. I'm going to pick -6. Why is -6 a good one? Because I know that when I square it, it's divisible by 3. So I'm going to do -1/3 times -6 squared minus 2 times -6 minus 4. -1/3 times positive 36 plus 12 minus 4. -12 plus 12 minus 4. That's going to be -4. Now if I pick, so this is 3 spaces away this way, if I pick 3 spaces away this way, this would be 0. And I said 0 is always good. When I plug 0 in for x here and x here, these 0 out. And so my answer would be -4 here as well. So -6, -4. Okay. If I want to pick another point, I'll just pick a point to the right. So I'm going to pick 3. 3 is a good point to pick. Because I know it's divisible when I square it by 1/3, so +3. So this is going to be -1/3 times +3 squared minus 2 times +3 minus 4. -1/3 times 9 minus 6 minus 4. That's going to be -3 minus 6 minus 4, which is going to be -9 minus 4, which is equal to -13. Okay. So we'll have to have a little trouble graphing that one. Okay. So my axis of symmetry, I had 3 spaces to the right, 3 spaces to the left. So I know I have this point right here. And then when I go 3 over, it's going to be, that just does not seem right. I just don't feel like that's -13. Yeah, it's going to be -13. So I go 3 over, and then 13 would be just about right here. So I apologize for the one off the graph. And so then if I go 3 over this way, so then I'd have another one that would be at -9. Or sorry, I said -3, -9, -13, so -9, -13. Sorry, my brain stopped working in the middle of the video. I'm sorry, guys. Okay, and so that's roughly what your graph would look like. And I apologize for the points that are off the graph. I should have made the graph a little bit different. I should have done -4. Should have had it up a little bit. Okay, so increasing intervals. So we'll talk about this again. My intervals of increasing, I know it's increasing from here to here, and we only look at our x values, so I know it's increasing from -infinity to -3, and then it's decreasing from here to here, so it's going to be decreasing from -3 to +infinity, and remember, you only use your x values for this. Your real solutions, we're going to say none because it doesn't cross your x-axis, and your y-intercept is at -4, okay, because that's where it crosses the y-axis. My end behavior, I'm going to just put, it's always going to be -infinity and +infinity for your x's as x goes to -infinity, so on my left-hand side, is my graph going up or down? So as my graph is going to the left, it is going down. So this is going to be -infinity. As my graph is going to the right, okay, so this is to the right, my graph is also going down. Okay, and that's about it. This is just review.